Hello everybody, I'm Anna. Welcome to our offices here in Elsevier. I hope you enjoyed this. This is my first meetup talk, so I'm a little bit nervous. So I'm going to talk to you about implicits. And I think it's safe to say that implicits are a little bit like the Marmite of Scala. Like, I love dropping implicits into a conversation and seeing people go, yay. So Martin Odelski really likes them. But if you follow some of the conversations happening on the Scala user group, for example, there's very public discussions, CTOs moving away their company's tech stack away from Scala because of implicits. There's Twitter storms happening where people say Scala should just ban them, rip them out completely. And if you read through those discussions, you will notice that there is one common theme that people have an issue with, and that is this sort of magic. Maybe it's the tech person in me, but I don't really associate magic with bad stuff. So when Alistair asked me to do this talk, I thought it would be a great chance to do some research, try to understand where this phobia is coming from, and try to come up with a few scenarios where I have used implicits in the past, I really like them, and why I wouldn't want to get rid of them at all. Having said that, we'll also talk about anti-patterns, and I will give you ample amount of warning of what not to do. So let's start traditionally. What's an implicit? It's a keyword. You can stick that keyword in front of a value, a function, definition. Oh, that doesn't work. In front of a class, an object, a trait, etc. And what that keyword does, it tells the compiler that every time it encounters a type error, it should just check its scope and see if there is something implicitly, magically defined for it. So let's have a look at an example. Here we have a function which takes in an implicit parameter of type string. And in my scope, I have an implicitly defined caret. So now I can call my function without the type, provided the compiler checks its scope, sees a caret, sticks it in there, hey presto. This is one type of implicit operation. This is called an implicit parameter. There is also another one, which is called an implicit conversion, and I will cover that when I talk about extension methods. But I just want to highlight one thing here. This is the first rule about implicits. You have a magic hat labeled implicits, that's the keyword, and those are the only definitions that the compiler will pick out to fill in the gaps. Let's have a look at another example. You can tell I was writing those slides over Easter because they're full of carrots and bunnies. So all of a sudden in our code we have an explicitly defined bunny which I can call with my function. Like, this function doesn't just take implicit parameters. You can explicitly provide it something. And you can see over here, this is a Scala worksheet. It prints your bunny, but it still prints your caret if the bunny is not provided to it. Rule number 2, the compiler prefers explicits. Let's have a look at something else. A sneaky broccoli is all of a sudden in the scope. The broccoli and the caret both have the same string, so when I call my function, the compiler will just throw up a massive fuss and basically say, this is too ambiguous, I can't do anything about it, make up your mind. This is rule number 3. You need to make sure that your implicits are defined non-ambiguously. Is that a word? There is one more rule, that rule is about context. And I need to go over that in a little bit more detail. So there are 2 types of context that the compiler knows about. The first one is the resolved context. The second one is extended on the next slide. So in your resolved context, you will have your declared implicits. So that's anything at like class or object level. Here you can see that IntelliJ is very helpfully trying to tell me, make sure you stick a type in there, even though that type could be inferred, but just listen to the IDE here. You can also import your implicits. A compiler doesn't really like that because it has to go through a lot of your imports to find the implicits that you're trying to introduce to scope. But it's a pattern that is popular if you're using, for example, asynchronous programming, and if you had to import your execution context that comes from your implicit globals. Do that in tests, don't do that in production. Wildcard imports are the last place the compiler looks at. So over here we have a kind of a shorthand way of saying, find me a type integral that is implicitly declared in your scope. And what's happening is we're bringing in all the imports, we're importing all the implicits defined on the integrals object. There's a lot of those, they don't really fit on the slide. That was resolved scope, and now we're looking at extended scope. So your extended scope are companion objects. So that's companion objects of all the classes which are involved in a conversion. So you're converting from a bunny to a broccoli, and the compiler will look at the companion objects of both of those classes. This isn't new to you if you've worked with Play frameworks to parse your JSON files. You've got the case class of a dragon and a companion object for that dragon which defines an implicit reads that gets you the dragon given a specific JSON. And the last bit of extended scope resolution is type hierarchy. So for example, if my dragon, well, you can't be a case class then, but if my dragon extended another class, that superclass would also be looked up, or any kind of a trait that you're extending from. And what's worth pointing out here is that, see, I have my object extending from basic implicits and an implicit vegetable defined here. If I was to uncomment that line, the carrot would be the thing that's replacing the vegetable. So you have some control over which implicits the compiler looks at. So we know the rules. Hopefully we're feeling a bit more comfortable at this stage, but what I'm basically saying is it's still a magical world, and you're walking around, you can pick up what looks like a stick, and all of a sudden you've grown another head, and that's rather bad, right? So it's really useful to reason about how you're using implicits in your code if you think about three aspects of them. Are they discoverable? How powerful are they? And how large is the scope that they can affect, and the scope you need to know? So keep that in mind. We'll go through two scenarios where implicits work great, and on each one of them I will kind of try to refer back to the aspects we're talking about. The first one is implicit context. In functional programming, we are told to define all of our input data into the function. And that makes a lot of sense because you don't want to do any side-effecting calls, pulling in some random stuff that you can't reason about. So for example, it's encouraged to define a class table which knows upfront what configuration, connection, objects it should be expecting. And then you can have functions on that table which obviously need to refer to it. That's better than doing a class level variable for unit testing reasons. I can just inject a dummy configuration or a dummy test connection and keep my code nice and modular. What we often end up with in this case is a sea of parameters, because like all of a sudden you've got to carry all of your inputs, and that's a lot of boilerplate code. So what Scala lets us do is group parameters into different groups, and then you can assign one of those groups to the implicit config. So that's what I'm doing over here. So now I can define my database configuration and connection in one place, and all of my functions which need it can take it implicitly. This is used all over the place, like execution context, Spark session. I mean, that's just to name some of the top two that come into my head. Why I think this is a really nice scenario is because those implicit definitions are really easy to see. They're on the class level or on the function level. You know exactly what to expect, what type to give. The power is kind of up for discussion. I'd say it's quite high because I hate doing typey, and it lets me skip a lot of that. And the scope of that can be large, depends on where you've got that, where you're using it. But the IDE can help you, and I will show you some tricks with the IDE as well. Scenario number 2, extension methods. If you come from Java or any other language, you know they're a bit of a nightmare to do. So imagine you have a class defined in another library or another package and you can't use it. You can't extend it, but you really want to use it in your code and you want to tell it to do something else. So what we can do in Scala is define a companion object to this class, the dragon, and inside the companion object, create an implicit class that does a conversion of sorts. So this implicit class takes in the can't extend it, can't touch it dragon and adds another method to it. So now in my code, I will call this dragon and I can actually refer back to one of the conversion methods I've just added to it. And you can see there is an underline on the fly method. That is IntelliJ telling you an implicit conversion is happening under a place. So you're basically taking one type, this old dragon you can't do anything with, and converting it to the functionality of your implicitly defined dragon with wings. Another beauty of doing it with an implicit class, as opposed to, for example, an implicit definition that returns the new type, is that you can make this implicit class implement a trait that you later added on in your code. This is fairly easy to discover, I'd say, mainly because of the underline. The power, medium to high, I think it's rather high, to be honest. And the scope is large, but you can see the underline. I don't think I'm going to do this. This will take me another 20 minutes. And type classes with implicit, it's a really nice topic. But in the interest of not keeping you too far away from your beer, I'm going to skip it. Yeah. I'm going to put the slides on GitHub, so if you guys want to check it out, this is a nice example of witches and villagers killing dragons implicitly. The two I mentioned, the last one I skipped, and a few others are all in Lee's blog post, which is really good, comprehensive, not just for this topic, but many other as well. So I encourage you to have a look at it. But then, what about the bad rep, right? Because so far it's just been good news. I think Scala implicit got their reputation from Martin Odersky. Because when he published the Pimp My Library paper, which talked about implicit conversions, he kind of said it's okay to just do an implicit definition that takes in a type that you already know about in your code and return a new type. And people went ahead and started doing it. So all of a sudden you've ended up in situations where your code base is changing the behavior and you don't know what's happening. Like here in this instance, it's totally okay for me to convert all of the integers in the code base to string. Should do that with my salary and adding zeros to it as well. This isn't so much an anti-pattern as an anti-behavior of the compiler. You can totally break type safety using implicits. So I can quite happily go and convert all of my strings to integers, and that will compile but blow up at runtime. The last one is a little bit more subtle. It's about changing the expected behavior that people expect of because they know the code base, right? So think of an example. When you're comparing two lists in Java and Scala, the behavior of the equals method differs. In Java, you're looking at memory pointers. Those lists are not the same. In Scala, however, you look at the parameters and compare them individually. They didn't think about that when they released wrappers Java and wrappers Scala. We found out. So then we were told, okay, stop using it, start using decorators. And what all of those anti-patterns have in common is they are so difficult to spot, and they have incredibly large power of doing damage. Yeah, the scope also, not a nice thing. But aside from not doing the bad stuff, not doing the anti-patterns, I think the rest of the warning with implicit comes down to just being a good developer, a good engineer, and a good human being. So if you're writing code that will be a nightmare for someone else to read because you're using so many implicits, maybe don't. Importing implicits, I would argue, hurts the readability of your code. Also, the compiler doesn't like it. The compiler doesn't like recursing through all of this complex hierarchical structure that you have defined in your code. So if you can keep your implicits close to the classes, as opposed to the parents, etc., then do so. You also want to be very specific with the types that you are converting, so don't go for something generic like a string, create a new type if you have to. And unit test your code, of course. That's gospel. So one other thing I picked up when I was doing the research into why people hate implicits is they're not too clear on the rules. Okay, we've covered the rules. They're not too clear on when to use them. They use them badly. But they also don't know the tools they're working with. And, we're not in medieval ages. We've got IDEs now, right? So have a look at whatever keyboard shortcut your IDE has. IntelliJ provides one for conversion, one for parameters. And do you remember when I mentioned the underline thing before? You can use whatever keyboard shortcut you've got to tell you exactly which implicit method created your object. Or in the example earlier with the carrot and the bunny, I can click on the method and see which implicit parameter was introduced. And Scala plugin has still a little bit of a way to go. It's kind of getting there. But for some strange, unhelpful reasons, they've decided to limit your search depth for implicit parameters to -1. I didn't know that until I did the research for this talk. So go ahead, people, change it to something a little bit more sensible. Or if you don't use IntelliJ and you want to compile with Scala C, have a look at the flags available to you. They are really useful if you want to debug and see what the compiler went through. Here are some of the resources I went through and I found to be very helpful. And in particular, Alex's talk, he is one of the developers of the Scala plugin for IntelliJ, and it's a dense talk, be warned. But he has some pretty good tips on how to not bog down the compiler with the speed. Scala Puzzlers is a really good book if you want to test your knowledge of the rules. And that's it from me, folks. I hope I've managed to clear some questions, shed some light. I've put the code examples on my GitHub. There's a link to slides in the README for that. If you want to go ahead and play with implicits, don't tweet me and don't tell me how much you hate me, because I'll cry a little. Thank you so much.